today we're going to be looking at solving E equations, and I'd also like to share with you a cool trick I learned about solving E equations using quadratics. First of all, let's refresh our memories with a slightly easy one. Here we have e to the power of x is equal to 2e to the power of 1 minus 2x. First we begin by applying natural logs to both sides. Then we take down the power of x, put it in front. But here, because this is quite complex, what we can do is we can split it up, because 2 times by e can be written as natural log of 2 plus the natural log of e. Then we bring down that power, over here, and then we can solve it like a normal equation, and you end up with, move the x's here, and you end up with x equals natural log of 2 plus 1 over 3, and that's your answer in its exact form. If you want it in decimal form, you can just plug that into your calculator and you're done. Today I was doing a C3 paper, as you do, and I had to find the point of intersection for these two graphs. So we've got 2e to the minus x is equal to e to the x minus 1. And I was really chuffed because it was 5 marks. But after playing with it for about half an hour and not getting values that actually work, I turned to the mark scheme. And in the mark scheme it said solve it using the quadratic method. And I thought, what's that? So I looked into it and now I'm going to share it with you. Okay, so first thing you want to do is get rid of the minus power, because it's not nice. So what we're going to do is we're going to multiply both sides by e to the power of x. So minus x cancels off with e to the power of x, and you're left with just 2 on this side. And then you want to expand this, and so you end up with e to the power of 2x minus e to the power of x. Now from here you can take everything to one side, just like you would with a quadratic equation. I hope this is starting to look familiar. So now you have something that looks kind of like a quadratic. If it helps you, you might want to write it out like a quadratic, because then it'll be easier to solve. So let's solve this quadratic. So here I have, well, this is what you get after you've solved the quadratic. If we look back at the graph, we can see that the x value is somewhere in the positive region. So our answer can't be minus 1. So we're going to look at 2. Now remember, our original equation said e to the power of x, not x. So e to the power of x is equal to 2. Now applying natural logarithms, this gives us x is equal to ln of 2. And if you plug that back into the equations, you end up with y is equal to 1. A really good way to practice these equations is to go on Desmos and make your own graphs. And then Desmos is a really cool website where you can draw graphs if you don't have a graphic calculator. So it will tell you the point of intersect, so that's where you'll find your answer, but you can practice by trying to solve the actual equation and seeing if you get the same as what the website says. So let's apply what we've just learnt here. E to the 2x minus e to the x minus 5 is equal to 0. You see we've written it out as a quadratic again. X squared minus x minus 5 is equal to 0. Now in this case we can't really factorize it using the other method, so we're going to use the equation. So after you plug in the values, you end up with 1 plus minus square root 21 all over 2. And this gives us e to the x is equal to 2.79. There's also a negative value, but you can already see that the point of intersection is in the positive region, so we're just going to look at that value for now. And then applying natural logs, you end up with x equals 1.02. And if I look on the actual Desmos graph on your device, then you'll notice that that's the correct answer. So you can just play along play around even with loads of equations and see if you get the answer. It's good practice. So yeah, thank you for watching. Don't forget to give it a thumbs up if you enjoyed it, and I look forward to seeing you next time. Oh, and I'm definitely going to be working on my intro, but yeah, bye.